Hi students, welcome to Conceptum classes. Today's our session is 12th class maths, vector algebra. In this session, we will discuss the basic concepts of vector, how to represent a vector, position a vector, direction cosines and direction ratios. Let us start with vector. In the earlier classes, you may have studied what are physical quantities and what are the types of physical quantities. So when we say physical quantities, these physical quantities, they are of two types: scalar quantities and vector quantities. Scalar quantities, they are the physical quantities having the magnitude only. They have the magnitude only. For example, let me take time. Time has magnitude. It is a scalar quantity. Let me take length. Length has magnitude only. Therefore, it's a scalar quantity. Let me take mass. Mass has magnitude only. Therefore, it's a scalar quantity. So, all these quantities having magnitude only, they are known as scalar quantities. Now, vector quantities. Vector quantities are the physical quantities having both magnitude and direction. Having both magnitude and direction. For example, if I take velocity, velocity is a vector quantity. It has both magnitude and direction. If I take acceleration, if I take force, so on. These are all vector quantities. So in short, we can say that vector quantities are those physical quantities which have both magnitude and direction. Velocity, acceleration, force, so on. These are some vector quantities. Now next is now a representation of a vector. A representation of a vector. So before discussing the representation of a vector, we must know what is a directed line. What is a directed line? डायरेक्टेड लाइन क्या होती है? वो लाइन जिसकी कोई डायरेक्शन होगी. Any line with a direction is a directed line. A line with a direction is called directed line. चलो मैंने यहाँ एक लाइन बनाई, इसको एक पर्टिकुलर डायरेक्शन. This arrow, it shows the direction. It shows the direction. So this is the directed line. Its direction is from west to east. Left side में west, right side में east. From west to east. Let me show this line. This is a directed line from south to north. This is a directed line from east to west. All these directed lines, they represent vectors. So a directed line represents a vector. A directed line represents a vector. But in the definition, we see that having magnitude and direction. Here we have discussed only direction, not magnitude. So when we study vectors, we study two things. We We study two things of the vectors. We study its magnitude and direction. When we say the directed line, it's a line with direction. That means it shows us the direction. Then what is the magnitude? What is the magnitude? Magnitude is the length. Magnitude is the length of the vector. Magnitude is the length of the vector. For example, let me take a directed line. Name this as A and this as B. If I say that this length of this AB is 3 units, that means length of vector AB, length of vector AB is 3. We can say that length of vector AB is 3 units. So this gives the length. This gives the length. So when we say length, length is the length of this directed line. Length of the if I suppose the length of this directed line AB is 3 units, that means the length of vector is 3. Now you pause the video and note it down. Now let this be a vector A and B. Now remember, this point A, it is called initial point of vector. It's called initial point of vector. Initial point. And this point B, it is called terminating point. A is called initial point and B is called terminating point. A is also called tail and B is also called head. A is either called initial point or we call it as tail, and B we call it as terminating point or we call it as head. Now length of vector AB, length of vector AB. When the arrow is shown over AB, it means length of vector AB. It is the modulus of AB. It is the modulus of AB. This modulus of AB, it shows the length of vector. It shows the length of vector. Or, in other words, let me take a vector. Let me name this vector by a single alphabet A. Then the length of vector here is A. Length of vector here is A. The length of vector is A. So either we can write length of the vector AB as modulus of AB, or if we represent the vector by a single alphabet A, then the length of vector is modulus of A. The length of vector is modulus of A. I hope you understand what I am saying. So this is the representation of vector. Now comes the position vector. The most important thing we are going to discuss now is the position vector. Now, position vector. What is a position vector? Now you consider a 3D system. Consider a 3D system. A 3D coordinate system. This is the x-axis. This is the y-axis. and this is the z axis. इसको समझने के लिए ये 3D कोऑर्डिनेट सिस्टम क्या है, आप जिस कमरे में बैठे हैं, जहां पर आप बैठे हैं, आप उसके एक कॉर्नर को लीजिए, कॉर्नर को लीजिए, कॉर्नर से एक एज ऊपर को जा रहा है, आपके कमरे के कॉर्नर से एक एज ऊपर को जा रहा है, समझ लीजिए ये z एक्सिस है, एक एज यहां फ्लोर के साथ साथ जा रहा है, समझ लीजिए ये y एक्सिस है, और एक एज यहां को जा रहा है फ्लोर के साथ साथ, समझ लीजिए ये x एक्सिस है. सो बच्चों, माय डियर स्टूडेंट्स, ये जो 3D कोऑर्डिनेट सिस्टम है, इट इज बेस्ड ऑन इमेजिनेशन. ये सब इमेजिनेशन का खेल है, जिसकी इमेजिनेशन जितनी स्ट्रांग होगी उसको उतना ही समझ आएगा. तो ये सिर्फ इमेजिनेशन का खेल है. तो आप इमेजिन करिए, विजुअलाइज करिए अपने इस कमरे को जहां पर आप बैठे हैं, ऊपर वाला एज z एक्सिस, एक एज यहां को और एक एज यहां को, एक x एक्सिस और दूसरा y एक्सिस. नाउ consider a point A here in the coordinate system, 3D coordinate system. You take a point A. This is the origin. And the coordinates of origin are 0, 0 and 0. Coordinates of the origin are 0, 0 and 0. Take a point A here. Let this distance from the origin on x-axis be x. Let this distance be y. And let this distance on the z-axis be z. Then the coordinates of A are x, y and z. This distance be x, this be y and this be z. Then the coordinates of A are x, y and z. And if we join OA, then the position vector of point A is vector OA. This vector OA, it is the position vector of point A. Here O is the terminating point, O is the initial point, and A is the terminating point. A is the terminating point. Coordinates of O are 0, 0 and 0, and coordinates of A are x, y and z. Therefore, length of this position vector OA, is equal to under root of x square plus y square plus z square. Is x square plus y square plus, how? कैसे? कि length of OA is under root of x square plus y square plus z square. तो बेटा आप याद करिए, 10th क्लास में कोऑर्डिनेट ज्योमेट्री आपने पढ़ी है, डिस्टेंस बिटवीन टू पॉइंट्स, it is under root of x2 minus x1 का square plus y2 minus y1 square plus z2 minus z1 square. x2 means x minus 0 का square, that's x square, y minus 0 का square, that's y square, z minus 0 square is z square. This gives the position length of the position vector OA. Now, length of position vector of any point can also be represented by R, modulus of R. So length of position vector, it is also can be represented by modulus of R, and you remember modulus of R is always equal to R. So here we can write this as R. The length of the vector OA can be R. So this is the position vector A. OA, position of point A is the position vector OA. Next is now direction, cosines and ratios, a very important topic. First you pause the video and note it down. Now, direction ratio, cosines and direction ratio. Again, consider a 3D coordinate system. This is x axis, this is y axis, and this is z axis. Now, let A be a point in this 3D coordinate system. Then what is OA? What is OA then? It is the position vector of A. Let the length of this position vector of A be R. चलो मान लिया इसकी लेंथ R है. मान लिया ये जो OA है, this OA, it makes angle alpha with x-axis के साथ एंगल अल्फा बनाएगी, y-axis के साथ बीटा एंगल बनाएगी और z-axis के साथ गामा एंगल बनाएगी. Let us suppose this OA, vector OA, position vector OA makes angle alpha with x-axis, angle beta with y-axis, and angle gamma with z-axis. All these alpha, beta, and gamma, they are positive angles. What are positive angles? Positive angles are the angles which are made in the anti-clockwise direction. वो एंगल जो anti-clockwise direction में, यहाँ आप इसकी direction देखिए, ये anti-clockwise direction है, ये anti-clockwise direction है, ये anti-clockwise, तो जो एंगल anti-clockwise direction में बनता है वो positive angle होता है. So that means here angle alpha, angle beta, and angle gamma are positive angles. Now from this A, you draw a perpendicular. You draw a perpendicular on y-axis, then on x-axis, then on z-axis, and you complete a parallelogram. Let this be x, this be y, and this be z. Now, these angles, alpha, beta, and gamma, which this position vector OA makes with x-axis and y-axis and z-axis, they are known as directive angles. Now, angles alpha, beta, and gamma are called direction angles. They are called direction angles. And when we take cosine of these angles, take cosine of these angles, take cosine of these angles, then we can write cos alpha, cos beta, and cos gamma. Then these cos alpha, cos beta, and cos gamma, they are known as direction cosines. They are known as direction cosines. Alpha, beta, and gamma, the angles which the position vector OA makes with x-axis, y-axis and z-axis. With x-axis, it makes an angle alpha. With y-axis, it makes an angle beta. And with z-axis, it makes an angle gamma. Then these alpha, beta, and gamma, they are called direction angles. And when we take cosines of these angles, we can write cos alpha, cos beta, and cos gamma. These are known as direction cosines. Now, cos alpha can be represented by L. Cos beta can be represented by M, and cos gamma can be represented by N. So that means L, M, and N, they are also direction cosines. We can say that L, M, and N are direction cosines. They are simply what? Direction cosines. Now, how to calculate the value of cos alpha, cos beta, and cos gamma? As I earlier said, this is the totally imagination. This is totally imagination. Now, let us see how to calculate the value of cos alpha, cos beta, and cos gamma. You pause the video and note it down. Name this point as on x-axis as P. Now, when we join AP, जब हम AP को join करेंगे, when we join AP, we get a triangle. हमें एक triangle मिलेगा, एक right angle triangle मिलेगा ऐसे. यहाँ इसका A है, यहाँ इसका B है, और यहाँ इसका O है, और ये एंगल ये अल्फा बनाता है. ऐसा एक ट्रायंगल मिलेगा और ये राइट एंगल ट्रायंगल है. समझने के लिए आप इस ट्रायंगल को लीजिए, यहां मैं इसको क्यों रख रहा हूं, ये इस ट्रायंगल को लीजिए समझने के लिए. ये ट्रायंगल है, ये ट्रायंगल है, इट्स अ राइट एंगल ट्रायंगल. तो यहां ये जो ट्रायंगल है, दिस OA मेक्स विद द y एक्सिस, यहां एंगल बीटा है. ऐसा ही ट्रायंगल x एक्सिस के साथ भी बनेगा, और ऐसा ही एक ट्रायंगल z एक्सिस के साथ भी बनेगा. जब ऐसा ही ट्रायंगल x एक्सिस के साथ बना तो उसका ये बेस एंगल वो अल्फा होगा. जब y एक्सिस के साथ बनेगा उसका बेस एंगल बीटा होगा, और जब z एक्सिस के साथ बनेगा तो उसका बेस एंगल गामा होगा. नाउ cos alpha, we know that cos theta is based by hypotenuse, so here cos alpha is OP by OA, OP over OA. What is the length of OP? You look here, length of OP is x. So that means cos alpha is equal to OP is x. What is the length of OA? That is r. And cos alpha is represented by L, or we can say L is equal to x by r, because modulus of r is also equal to r. So L is equal to x by r. Similarly, m is equal to, m किसके बराबर होगा? y by r, sin beta, cos beta, and n is equal to z by r, cos gamma. जब cos alpha x by r होगा तो cos beta y by r होगा. cos beta यहाँ मैं लिखता हूँ, cos alpha is x by r, cos beta it will be y by r, and cos gamma it will be z by r. Now cos alpha is represented by L, that means L is equal to x by r. Cos beta is represented by M, that means M is equal to y by r, and N is equal to z by r. Therefore we summarize here that L is equal to x by r, M is equal to y by r, and N is equal to z by r. These are direction cosines. I hope you understand what I am saying. कि डायरेक्शन को साइंस हम कैसे निकालें. तो इसको pause the video and note it down. We will move to direction ratios. Now direction ratios. What are direction ratios? Direction ratios are the numbers say A, B and C. A, B and C. मान लिया डायरेक्शन रेशियोज वो नंबर्स होते हैं. मान लिया यहाँ नंबर है A, B है, A, B and C, which are proportional, to the direction cosines. वो नंबर जो डायरेक्शन कोसाइंस के प्रोपोर्शनल होंगे उनको कहते हैं डायरेक्शन रेशियोज. तो यहां मैंने तीन नंबर रखे A, B and C. So that means L, M and N, they are direction ratios. And A, B and C must be proportional to these direction ratios. That means L by A must be equal to M by B must be equal to N by C must be equal to a constant. L by A must be equal to M by B must be equal to N by C must be equal to a constant. Now, in the direction ratio cosines, you have studied that L is equal to X by A. M is equal to Y by X by R, sorry. Y is equal to M is equal to Y by R and N is equal to Z by R. अभी आपने देखा डायरेक्शन कोसाइंस में. तो यहां अगर मैं करूंगा that means X is equal to LR. Y is equal to MR and Z is equal to NR. तो ये LR, MR and NR, these are the numbers. These are the numbers which are proportional. Here, which are proportional. Now, this L by A is equal to M by B is equal to N by C. It can be also written as A by L is equal to B by M is equal to C by N. One and the same thing, proportional है. अब यहाँ ये LR इसको मैं A मानता हूँ, ये MR इसको मैं B मानता हूँ, NR को C मानता हूँ. It will be LR by L is equal to MR by M equal to NR by C, NR by N. Here L and L cancels, M and M cancels, N and N cancels. This is equal to R, which is a constant. So therefore, these numbers LR, MR and NR, LR, MR and NR, these are actually the direction ratios of A. These are ratios. I hope you understand. So in the next chapter, we shall start with, next session we shall start with types of vectors. You make a note of this and study yourself. Any comments? You can comment on it on the session. I hope you understand. So till next session, goodbye. Have a nice day.